Hello and welcome to the second practicals. I'm Julia and I'm here with Michi.
Yeah.
So today our goal is to really start programming and writing our first program, more or less.
So a bit more than we have seen in the last lecture, last Thursday. But it's not only the programming, but we have a lot of things to do again.
Yes, so let's take a look. We'll start with some really short organizational matters, and then we'll show you how you can program your first program in our virtual machine with our environment. So not only on online GDB.
Yeah, so they cheated a bit in the lecture, just doing it in online GDB. We do real programming today.
Yes, then we'll talk about data types and operators. So a refresher from the last lecture. Then you'll talk a bit about binary representation, which is hopefully also a recap.
Yeah, but maybe it's also a good thing to go through it again one more time.
And then after talking about ASCII a bit and characters, we'll start with the first larger program, so a bit more complex.
Yeah, I'm really looking forward to program this. Yeah, organizational matters. We had some confusion in general. If we read through Studo, for example, or also on our Discord, what are the different things, just to clarify them once again. Currently, the first coding session is open. You can register to the coding session in the Teach Center, and as a preparation task for the coding session, you need to do the corresponding homework, and the corresponding homework is about Linux and Git, where you set up the virtual machine and do some basic Linux commands and work with Git the first time. So this is for the next 2 weeks. The coding session 1 is open, and the homework 1 needs to be submitted before you go to the coding session, before your coding session time slot takes place.
So let's continue with the weekly exercises, which is something different. These are just some small exercises you should do every week so you can keep up with the lecture and the practicals. There are already 3 exercises from last week, and we have 4 more exercises for this week, and they will be available later after the lecture. Please make sure you register in online GDB with the correct username. I think we still saw some which had the wrong username. Just as a reminder, if you go to coding.dugrants.at/home, that's also linked on our homepage, here you see your username and you can click copy. It's blurred out, so you really have to click copy, but you can also view it.
This needs to be really used for registration, otherwise we don't find you there. And I think, as you mentioned, we have currently 400 registration on online GDB, and 5 to 10 people did not manage to use the correct username. So if you feel that you didn't see this weird name here on this webpage, then go through the guides again and copy it correspondingly.
You can also change your name in online GDB. So if you already registered and joined, you can just change your name to the correct one, and it should work. Okay, then also personal question hour. They are every Tuesday from 16 o'clock to 19 o'clock, but you have to register in Teach Center before you attend them, so we don't have to wait the full 3 hours to see if someone shows up, and we can plan beforehand. And if you cannot attend, then please deregister again. So if you registered for a coding session, then either solved your problem or you don't have time, then please deregister. You can do this even on the same day as the personal question hours. I think it just needs to be 4 hours in advance.
Yeah, 4 hours before the PQ8 personal question hour, you can deregister. And on this Tuesday, there were 4 registrations. 2 showed up, 2 did not show up. And 2 of our tutors, including you, sit there for 1 hour, nobody showed up. So this is not why we wait there. we could do something better this time. Yeah, so please deregister if you do not use them.
But you're, of course, always invited to attend the personal question hours.
Yes, of course. So please register and come, but please don't register just for the purpose of registration or something like that. Yeah. And one more thing, as I mentioned before, not everyone completely understood how our course works. We know it's a bit difficult now with the weekly exercises, with the homeworks and so on and so forth. But it should be possible for everyone that he or she goes to our course website, which is Notion, or it's just coding.tugraz.at. And I just want to remind you, if you're on this website, you go to the practicals, that's what we're doing here, and go to the guide. We really try to describe everything you need to know. So you have a task overview, and then you have a category about organization. What are the important things? You have to make yourself familiar. How to set up your device, step 1, step 2, step 3. And then working on an assignment, not so relevant at the current moment, but please go through the guide, everything is explained there. And also for a coding session, everything is explained. And it's really said, okay, you need to pick the time slot, you need to prepare the homework, and then you go to the coding session. Everything is explained there, just read through it. Okay.
Then we can start with the first topic.
That was the boring stuff, more or less. Hello world.
Yes.
Okay, so we go to a virtual machine, I would say. Now I register here. Okay, this is our virtual machine. Now, how can we start programming now? I mean, I don't know. So first thing, maybe we should create a folder where we want to work. Yeah.
So let's do it with the terminal, because that's how we did it last time.
Make it a bit larger that everyone can read.
And if you remember correctly, you can use make here to create a directory or a folder, and let's just call it, I don't know, practicals 2.
Yeah, practicals 2. Okay.
Yes, and then we can change into that new directory.
Spoiled it already.
With cd.
cd and then the name of the folder, cd practicals 2, and remember here we see that we're on the correct folder with the practicals 2. And now we need the file to write the first program. So how can we create the file? This was this touch command. So touch, and then let's call it just hello world.c. Okay, now it worked. And one last, I think this was the last command that we discussed, really, ls. We can list all the files in this folder. Okay, we have this hello world.c.
And now we'll normally work with Visual Studio Code to write our programs, which is just the editor. And now you could open Visual Studio Code and then open the directory where we have our file. But there is also a command for Visual Studio Code, which is just code, and then we specify the current directory.
So this dot means current directory.
Yeah.
Didn't test it, but it should work. Yeah.
Yes, and as you can see, we need to trust. Okay. It opened our directory practicals 2. Maybe you can zoom in.
Yeah.
It opened our directory practicals 2. And in here we see our .c file where we want to start programming.
Okay, then we maybe open it. And don't we have installed this already? Yeah.
Yeah, okay.
So we just ignore this these messages here. Update. You can update it if you like. It's no problem if you update Visual Studio Code. And yeah, we can start programming now. So maybe we go through it one more time. What is the important thing? I will start in the very top. What is this?
Okay, so first we need to include some library, something that's already written by other programmers for us. so we can actually communicate with the user. And this is std.io or standard.io, so standard input-output, where you can input something and output something from our program.
So that we have text output, for
Yeah.
example. Okay, then the next thing, we need to create this main function here.
Yes. Okay, so this now was a lot, but I think for now you can just see this as something that is called, or something where the execution of your program starts at the beginning when you first start it up.
So if you have like a cooking recipe, then you would not go to the ingredients, but you would go to the first step,
Yes.
what you need to cook, and then the first step would be like, if I write a comment here, it would start here. So if this maybe it's not located here somewhere, it's not here below, it's really here, the first line into this main function.
Yeah, and what exactly this main function is, you'll learn later on.
Yeah.
So just don't be intimidated by it. Just know that in this main here, our program starts executing.
And everything except for this std.io we will put into the main function. Nothing will be outside at the current moment. Okay, and now, as it's called Hello World, we need to print something. So we use printf, and I will write here Hello World. Okay, and this was again a lot what we've written here. Should I now explain it?
Yeah.
Okay. So printf is a function that in our case now takes one argument. Yeah, so the argument is this thing here in the middle, and yeah, printf just will print this message as the name suggests already, and what we write here will be printed. And now we need to, if we have more than one character, we need to use those double quotes at the beginning and at the end, and then everything which is between the double quotes will be printed. And in particular, this last sign here, this \n, this is not two letters, it's just a single letter, which is not visible for us, but it just indicates that the line should be broken.
Yeah, so a new line should start.
Okay.
Yeah, more generally, if you see anything with this backslash here, here you can always assume that this is some special thing afterwards, and not just the end. Yeah.
Okay, so this is now the code, and what to do with it now? How can we run it?
Okay, now we need some way to execute it, yes. And of course, we'll also do that in the terminal.
So we open the terminal now here, maybe. Maybe I can make it a bit smaller. Yeah, hopefully we can see everything.
Maybe we can display the contents of the file before doing this.
Okay.
So just some quick recap from last time.
The cat command, and now we want to display hello world.c, and yeah, we can see. Maybe I need to. Can I do it? No, I can't do it this way. Maybe so. Yeah. Okay. So we see this is the content. This was the command from before. This is the content, and if I would not have resized it, probably everything would be displayed. Now it works. Yeah. Now I have a question. In this was really a pain with the terminal. Is there also an option that I don't need to open like this terminal in a second window?
Yes. So we can basically do everything inside of VS Code, and up here we see terminal, and then we can click new terminal, and now we have one right inside VS Code.
Okay, so this is now really just below the file.
Yeah.
This looks more convenient. And this behaves completely the same. So I can again type, for example, cat hello world.c. Notice that we are already in the correct folder. And maybe you, okay, it's just some delay here. The content is displayed of the file. Okay, now we see the content of the code file, but how can we now execute the code?
Yeah, so that's basically 2 steps.
Okay.
We need to do now. First, C is not something our computer can read. So we need to more or less translate it or compile it to something our hardware, our machine can execute.
So we need to call this compiler. We use clang, and with -o we can define how our program should be named. Yeah, so the result should be named now the name that we specify here. I could take, for example, I don't know, hello world. But notice I don't write the .c because it should be a new file.
Yes. So here you always specify a new file, and this file will then be an executable binary. So you may know this from Windows as a .exe, which you can execute, and then our program will run. And this is and it will be saved with this name. Yeah.
And now we need to tell the compiler which file should be compiled, which program it should use. And now we need to type the hello world.c.
So we take the hello world.c and compile it into something which can actually be executed on our computer.
Now let's try it. No output, so usually no output indicates that it works. And now maybe let's see here. Okay, we also have now this file here, which cannot be displayed because this is now a language which our computer can understand, but we usually not, or we can barely understand the language. So close it again, it's not so important what its content is, but this is our program translated for the computer. And now how can we say to the computer, please run our program?
Well, it's similar to how we run any other program in the terminal, like cat or clang. We need to specify the name. But because now our binary is in the current directory, we need // in front of it. So this will specify, okay, look for the thing we want to execute in the current directory.
And then hello world. And with the C or without the C now?
Yeah, without the C.
Without the C.
Because the C file is the thing which is readable for us humans. And without the C is the file for the computer.
And now I've just pressed enter and it really displayed hello world. So this is the expected result. If I would type now hello world.c, the computer tells me he does not know what to do with the hello world.c. So we executed now the right file again. And just for curiosity now, we talked about this \n. I just remove it. So we've made changes. Now I cannot execute my program directly because we only changed the .c file and not the translation for the computer. So we need to translate it again with clang.
Like this. And as you might remember from last time, with the up arrow in the terminal, you can cycle through the previous executed commands, so you don't need to type them in again.
And then we execute it. Yeah, okay, but sometimes the keyboard is... I'm sorry for that. Okay. So we compile it again. Does it work now? Please do it on. Yeah, okay.
And then we can execute it. And you can see now there is not a new line at the end. And so our prompt, this is what it's called, which asks us what we should input, directly starts after the output of our program.
And this usually doesn't look so nice. So that's why we have this \n here. And I also learned that the Bluetooth keyboard is maybe better than a keyboard where we do not find the large and the smaller symbol, but it's still not the best. Okay. Do you have any questions which are relevant for now in the chat?
I didn't read the chat.
Okay, but I think it's everything.
I think it's fine. It was just some setup questions, but
Yeah.
not about the actual code.
Okay.
Yeah. Yeah. I think David answered most of them.
Okay. Perfect. Then just for you, if you download the slides later, we also put the code here, and we also have the commands here that we typed. Yeah, so this is everything should be clear. We have seen this in the terminal. Okay.
Yeah. And maybe just one more time. Every time you change the C file, you need to run both commands again. So first compiling it again and then running the program again.
Otherwise, we'd only change what we can read, but the computer would still use the old version.
Okay, so let's continue with our data types and operators. So a recap from last lecture. And maybe we'll now also look at it from a practical side. Okay, so to recap, what is actually data? Well, data is just some information, and this information is stored in our computer in some way. And in our case, it's stored in binary, so with zeros and ones. But without any context to this data, so without any context to these 0 or 1s, without any additional information, this data is more or less meaningless because we don't know how we should interpret those zeros as 1 or 1s. I don't know, is it text or are these just numbers? We don't know. And as an example, we have just a variable x, and on the computer, this value in binary is stored. And without any additional information, we can't say anything about that. So this is where data types come in, because data types give our data more meaning. And we can say, okay, our data has a specific data type. So for example, remember this example from before with this variable x, which has some data. If we now say that x has the data type of an integer, or in C we write int x, and then 65, then we know that this data here, which is binary, is the same as this 65, which is our decimal representation of this data. So now we can say, okay, this data here should be interpreted as a number. But we could also say, okay, x has the data type character, and now x should be interpreted as a character. So we say char, which stands for character x, and then with single quotes we specify characters, the big A.
Now this big A and the 65 both have the same representation for the computer.
So 65 and this big A both correspond to this data, to this information. But for us, these are two different things because one is a number and one is a character. So with this data type, we have more meaning. But also, we can name our variables to give additional context. Now, maybe not to the computer, but just for us programmers. So for example, instead of just saying int x equals 65, we can say, okay, this is our age. And now this becomes more apparent that this 65, this number should be, is the age of someone. Or maybe we could say we are using a weird grading system where we grade with characters, that this is our exam grade and we got an A.
So it's not just a number and a character now, but we really, if we look at the variable, we know that this has some more meaning in our program.
So And now that we know what data types are, so they just tell us how we should interpret data, we can look at operators, because these operators, as the name implies, they operate on data. So they transform data into something else. And to do this, they of course also need this context, because maybe if I add numbers, they need to behave differently if I have a float or an integer.
What was a float again?
Yeah, so as you might remember from last lecture, the float is a floating point number, so a decimal number, so something with a dot.
Okay, 3.5,
Yeah.
for example. Yeah.
And an integer, so eine Ganzzahl is, for example, 5.
Mm-hmm.
Yeah, and they need data types. So, and these operators more often take one or more data values. Most often they are unary or binary. So they take two variables or something different, just two values, which represent data, and then act on this data. And then they output some new data type, or maybe some data that's data with some type, some new data, which could be the same or a different data type. So maybe this was a bit abstract, so I will give you an example. This should hopefully be pretty simple. We define an integer x as a new variable, and this variable should have the value 1 plus 2. And here plus is our operator. This operator right now takes two integers, so it produces a new integer.
Mm-hmm.
So as you might imagine, now the operator, what the output of this addition is, depends on which values we use and which data type of values we use.
Mm-hmm.
So the operator works differently for both. So let's start with some examples. If we add two integers together, we of course get another integer. So the integer 1 plus the integer 2 equals the value 3, which is also an integer.
Mm-hmm.
Then we can also do this with floats, of course. If we add two floats, we'll get a float again. And here in C, I don't know if they saw this last time, if you write an F after a number, then it's a float. So it's a literal for a float.
Okay, otherwise if we wouldn't write this F here, we would have a double.
Yeah.
But both float and double are data types which can also display fractional numbers.
Mm-hmm. And here, if we add two floats, we'll get another float with the value 3. Yeah, and then maybe something more interesting. What now happens if we take an integer and a float? Well, this also produces a float. So if we have the integer 1 and the float with the value 2, we get a float with the value 3.
Why is that?
Yeah, so in C, typically the data type, if you use an operator on two data types, the data type which has less precision, so the integer can't represent fractional numbers, will be promoted to the data type with higher precision. So the integer will be promoted to a float.
Mm-hmm.
So this one here is converted to a float and then added with this other float. And float plus a float, we get a new float.
Also, for example, so in the last line, if you would add 1 plus 2.5, for example, and the result would be an integer, then 1 plus 2.5 is 3.5, and we could only store an integer in the result, so the result would be, I don't know, 3, 4, but we will lose some information there. And as we do not want to lose information, we really need to take the more precise data type, which is the float in our case, and then really the result 3.5 can be stored.
And that's what C does for us. So we just write 1 plus something else. Okay, but now to something more interesting. What happens if we divide two integers? Well, both are integers, so the outcoming data type is also the integers. It's also an integer. So what happens now if we, for example, do 5 divided by 1?
By 2.
By 2, sorry.
Yeah.
5 divided by 2. The output would be a fractional number.
Yeah, so if I think mathematically it would be 2.5, but now what is the output?
But we have an integer here, so this can't be stored.
Yeah, okay, so
So one might think that maybe it's 3 because it's 2.5, which we should round up. But let's try it out.
And this is now a really important thing for you.
Yeah.
If you don't know the answer to some question, it's not, you don't need to ask somebody for such question. You don't need to look this up on a book. Just try it on your own. Just write a short program, put in the expression that you want to know, and then you see some result. And then maybe you have questions, why is it this result? Yeah, and then ask the question, why is it this? But try it out, try everything in short programs. You will learn a lot with that.
Yeah. So let's just type in our example. We had...
Should I type with the keyboard? Yeah.
We had the integer x equals 5 divided by 2.
And now print it, I would assume.
Now
So if we want to print something, the value of a variable, we cannot write it directly here, but we need to specify a format string. I hope you have seen this last time in the lecture. So this D is for decimal interpretation of the integer. I will also write a \n, and I need to specify the x, that the x will be filled into the %d.
Yeah, so we need these format specifiers to format our string, and that's also why it's called printf, because we are printing something formatted. Okay, then let's compile it again. We always need to do it when we change our program and run it again. And we can see, okay, the answer is 2. So C apparently doesn't round anything, it just cuts off the values after the dot.
So we have 2.5 and say, okay, 0.5, I don't care about this, we cannot store this, just take the 2. And most of you in the chat answered it correctly. But it's no problem if you don't know it yet. Now you learned something. This is really nice, I think.
Yeah. So this was the example. Let's experiment some more. As we know now from these few examples with this promotion, if we divide an integer by a float, we get a new float. So maybe this now is the value we wanted.
So we expect now to have really 2.5.
Yeah.
Okay.
So let's try it out. We divide here by a float. And then here in the front, we make x a float now.
Okay, now you also need to adapt the format string.
So f for float, the d was just for integers.
Okay.
Okay, let's try it out. And as we can see now, the integer 5 really got promoted to a float, and the result of this computation now is 2.5. And this is stored in the float here.
Okay, so this is really fine now. Is this also the same if, for example, the 5 would be a float and the 2 would be an integer? So this doesn't change. If we would have here the situation, like this situation, so both are floats, then the result is very naturally a float. But also in this case, if we have a float and divide it by an integer, in all these cases we receive a float as the result.
So we have the question, but is the 5 now a float or an int? I think to the thing we had before. Well, the 5 here, if you write it like that, really is just an integer. But when we use this operator, it will be converted into a float, and then the division will happen.
Maybe, I'm not sure, we can hover. So it also states here the 5 is an integer, and if we hover over this number, it states it's a float, it's 2.0. Why there are so many zeros in the output? It's just because if you specify the %f as the output, the output, I don't know, in this case we have 6 numbers after decimal point. You can also specify, we can change this %f such that we have exactly 2 numbers after decimal point, for example.
Okay.
Do you have something else here?
I think.
Yeah.
Yeah.
So this, we have seen this, and now, now we are a bit late in time. Maybe can I copy that?
Yes.
Okay. Maybe we have. Very fine. We have this situation. So when we print the result, so let me explain it. We have an x as an integer, the y as an integer, and now the result is a float, okay, because we know there should be a floating point, the result, but the x and the y are both integers.
Yeah.
And I cannot just change it here.
So assume these two are variables which need to be integers, but now we want to divide them and actually get a float as an output. So let's try this now. Okay, now we get a float because here the result is a float, but the division is not correct. We just get this 2.
Why is that? This is simply because we said before in the division, if we have 2 integers, the result will be an integer.
And then when we try to save this integer in this float, then C realizes, okay, this needs to be a float, and it will be converted after the division already took place and where we lost the .5.
Yeah, so this is the problem here. Now the question is, can we change it? Yeah, maybe go to the slides. Typecasts. And this already happened a lot of times here without mentioning it explicitly. But this basically means we have a data type and we change the data type, the type of the data. And this can be done implicitly, as we have seen this now in this example, for example. So we have an integer x, and we say now a float y should also be the x. And this is possible.
And the x, the 5, is converted to a float.
And we don't need to specify anything here. It just happens automatically. And we also saw the reversed thing here. So we have a float y, which has some value. And if we now say, okay, this should be an x and not a y. I'm sorry. So float x equals 5.75. And if we now say the integer y should be x, so the 5.75 from before, this also is possible. However, here we lose the information, so everything after the decimal point, because we store the result in an integer. But this is possible. We can just write it this way. It works. It's just doing it implicitly. But this is not enough now, as we've seen before. We maybe want to do it explicitly. And to do this, we need to write the data type in which we want to convert it in front of the variable name. So in this example, we need to write float of x. Then this whole expression becomes already a float, and then the float gets stored into the y. And now we can also use this in the example, in the division. So we can say, for example, it's enough if we do it for the x. I would just write it in braces and write here, I'm so sorry.
Do you need to press the same key again or it won't stop?
Really? Okay.
Yes.
No, I just need to wait.
Why can't I press
Wait,
Control and backspace?
I can do it.
Okay, so here we can just write into these parentheses the new type x should have. And we want to convert this x to a float, because now we have the division between a float and an integer, which should yield a float.
Then try it out. Compile it and run it.
And now it works again.
This is very nice. So we can also, if we have these two integers, we can convert one into a float, do then the division, and then we really get the float as the result. And again, it doesn't matter if we only do it for the x, only do it for the y, this float conversion, or do it for both. In all cases, we get the float as a result.
Yes. Okay.
Yeah.
Maybe here just a side note.
Yeah.
Float and integers are of course stored differently on the computer. This means that when you cast this value here, this integer x to a float, it will also change the underlying data so that it represents the same number as a float. So the bit representation, the binary representation may change.
Mm-hmm. Yeah, my keyboard doesn't work. Yeah, hope, yeah, okay. I probably will not even touch it anymore.
Okay.
Yeah, binary representation. We will just go through it very, very quickly.
You should know this from other courses.
Yeah, so a bit has two states. It's either 0 or 1. And a byte is just a collection of 8 bits. So we have, if we have a byte, for each of the 8 bits, we have 2 possible states. How many combinations do we have? Here 2 times, there is no answer, sorry. So we have, for the first bit, we have 2 combinations times 2 combinations for the second bit times 2 combinations for the third bit, and so on. So we have 2 to the 8, and if you calculate this, it's 256 possible combinations. So a byte can represent 256 values. Now, how does this work now? If we have just this byte, which consists of 8 zeros, then this corresponds to the value 0. And if we count up, now all the bits are set to 0 except for the last one, and then we have the number 1. And now imagine if you have this expression and you add 1 to it, then if you do this addition that you learned in the school, then you would add 1 to this last bit, would be a 2. 2 cannot represent it because we have only 0 and 1. So we need to write a 0 and have as a carry. Das, was man in der Addition mitnimmt eben. We have 1 as the carry, and if we add 1 and 0, we have 1. So this is the representation of 2. And now this it goes along. If we take 3, we just add 1 here again, and if we have 4, we would add 1 to this last bit. It becomes 0. We have 1 as a carry, so we need to add 1 to the second bit here. If we have 1 and 1, we get 0. We have again 1 as a carry. 1 and 0 becomes 1, and we're done. So this is the way it works when we count it. Hope this is just a recap for you. Okay, now skip a bit through it. Yeah, so we could also, if we have the binary representation, how can we get to the number? So this last bit has the value 2 to the power of 0, which is 1. This bit has the value 2 to the power of 1, so we get 2. And if both are set, we need, of course, to add this. So 2 to the power of 1 plus 2 to the power of 0, 2 plus 1 is 3. And for the fourth bit, yeah, you see the pattern. This is 2 to the power of 0, 1, 2. And 2 to the power of 2 equals exactly 4. Yeah, okay, I hope you have seen this. And now, just always skip through the example. If we have this binary number, we can just go through the bits, calculate these powers. So we have the bit 1 here, this is then 4, this is 8, 16, but this is 0, so we don't count this. 32, yeah, we have this here. 64, we don't have it here because it's 0, and 128, and if we add this, we get 173. Okay, now with the characters, we need to rush through it a bit. It's just a recap here. So if we have this binary number here, then we can perform the same calculation. So we would get here 2 to the power of 0 plus 2 to the power of 6 and 2 to the power of 5 and 6. So we get the value 97. And now there exists this ASCII table. You saw this last lecture. And in this ASCII table, you can look up the decimal number. And in our case, this is 97. And see which character representation this value has. In our case, this is, for example, A. And now we've seen this before already. Now we have 2 different interpretations of the same binary number. So this is the binary number. One interpretation is interpret this as an integer, or one is that we do this conversion to the character. Yeah, we go through it on the slide, I think. Yeah, our time is too precious that we lose it now with this example here. So if we think about these characters now, we have a character little a, and the character little a, this is one representation. The other representation was, as we've seen before, 97. So I wrote this here as a comment. This character a, if we interpret it as an integer, would have the value 97. Now, if we have a number, we can, of course, subtract the number. So we could also subtract 32 from it. So we have this little a minus 32, get the value 65 out of it. And if we have the value 65...
As we have seen before.
Really? Yeah, this was your example before. Yeah. We saw if we interpret 65, so if you think about the binary representation of 65 and interpret the binary representation of 65 as a character, we get a large A. And if we would execute this program now with the A, then we would see, okay, the character is really a large A and the value is 65.
Should we?
Yeah, just copy it to the virtual machine. Oh, you can also do it here.
You have a warning. You have written A 2 times the big A.
But I want both large A's printed.
Oh, okay. Oh, yeah, okay.
So you can ignore everything where warning is standing here. We have not discussed this so far, but this is the output of the program. And yeah, once it's the large A and it has the decimal representation 65. Yeah, okay. And one more thing, also maybe I've seen this in the weekly exercises already. I want to show you that the character 0 is not the same as the number 0. Yeah. So this character 0 has again some binary representation, or if we have some binary representation, and you can interpret it as the character 0.
And we can look at this number representation by just using the decimal or %t specifier in printf.
And we do the same now for the number, which has the value 0. So the second printf is clear, it will be 0. And now I can press run, right? We see if we take the character 0 and interpret it as an integer, it now has the value 48. So the character 0 and the number 0 are not the same in our case. It might be a bit confusing at the very beginning, but it's like the A or the Z or whatever letter you take. It also is just one character and also has some representation. Yeah. Okay, this was everything about these character things. I think you have seen this already a lot in the lecture last time. And now we're at the very exciting part.
Yes, we'll now try writing our first larger program, and you prepared something for us.
Yeah, it's already a legend, more or less. So I did this exercise in the last 4 years 3 times. But with a difference, today we do a wine barrel instead of a beer barrel. Now it looks very confusing. Yeah, mathematical problem. We need to calculate a volume, and maybe you've seen this at school already. But yeah, we don't want to keep it too difficult. We want to focus on the programming part today. Okay, we take the wine barrel. It's like curvy. And turfy is too hard for us. Now, forget about the curvy thing. We only consider the violet thing, then go up to the red thing, go over to the side, go down to the violet thing, go to the bottom and do the same on the opposite side. So we make it a very ugly formed wine barrel, but it's very easy to compute now. Just keep in mind that we have some height. Also now the barrel is flipped, but it should be the height, of course. And 1/6 of the height is in this left violet thing, 1/6 is in the right violet thing, and 2/3 are in the red thing here in the middle. And we have a small diameter, so this is of the violet thing, and a large diameter, which is of the red thing. Some League of Legends fans here in the chat. Okay. How can we calculate this? We want to be very fast here. Yeah, we know this already. How to compute the volume of a cylinder? It's just pi times the radius squared times the height. And if we take this for the violet area, remember this was the bit at the beginning and the bit at the end. We said, so we plug it into the formula, the pi is the same. Now we have the small diameter, because the violet thing was smaller than the red thing. Need to halve it, because we need the radius instead of the diameter. Square it, and multiply it by the height. And if we go back to the drawing here, we said if we take both violet areas at the same time, it's 1/3 of the total height. Yeah, and if we go through the formula one more time and rephrase it, we get this representation. And for the red area, we do the same, pi times the larger diameter squared, and now 2/3 of the height are the red area. So we get, if we make it a bit more beautiful, we get this formula. Yeah. So we have one sentence. We have pi times h divided by 3 in both. So we just need to add these and multiply here. So we just get this formula here. Pi times h divided by 3 times something with the smaller and the larger diameter. Yeah.
If you didn't follow, that's not a problem. You just need the result basically of your calculations. And it should be pretty easy to understand. It's just some basic arithmetic. You can look at this at home.
Yeah. So everyone who did not get the formula, just this is the result. We need to calculate this formula in our program.
Yeah.
Okay. How to solve this now? We need to do several steps here. The first thing, of course, is we need inputs. Yeah, we need to specify the size of the wine barrel. So we need to ask the user for input of the small diameter, for the large diameter, and for the height. Mm-hmm. Yeah, so we need to get these user inputs. So this will be the first thing to do. Then we need to calculate the volume, of course, yeah, because we need to plug the values into the formula, calculate the volume, yeah. So we have the volume now, and now it would be really fine that we also display the result to the user, so we need to output the result.
So basically we're just doing a program which asks us what the size of the barrel is and then calculates the volume for us.
Yeah.
Then
Let's start coding. Now
I can try.
You try it, okay. So we already prepared a short comment here. Maybe you can copy the comment to the file.
I'll close this so we have a bit more space.
Yeah, just that we always see the formula.
Okay, so this is just the formula we came up with. We want those parameters as an input, and then we also have an example here to test our program.
Okay, so we said we need to start with the input. So
let's create maybe variables.
Okay, yeah, you're right.
Yeah.
We need to store the input somewhere.
So as you remember from the lecture, scanf, you need to specify some variable. And therefore let's create some. Maybe start with the height.
Okay, so we set the height to 0 in the first place.
And then we want to print something where the user has to type in,
So maybe just height in, we have now centimeters, but it doesn't matter. Everything is centimeter, yeah.
We print this, and then immediately after, we can use scanf to ask for input. Here we also need to specify what we want to read, and it's the same as in printf. So %d because we have an integer.
Yeah, so decimal input, yeah.
And then we just specify the height variable.
And now we learned something here. We need to write the and sign before.
What this exactly means, you will learn later.
Yeah.
But just for now, accept that you need it with the scanf. And okay, I can do this.
Okay.
Then maybe with the small diameter, because we have those 2 diameters.
But maybe before we continue, can we maybe test what we have done so far, that we see whether it really works?
Yeah, we can do that. So should I go back to the slides or?
No, we test our program now. So
okay, so let's just execute it.
We compile
it. We run it. Okay, this works. It asks us height in centimeters, maybe 50, I don't know. But we can see if this really worked.
Maybe we can print the height now to the output, that we can see whether this really worked.
So let's just directly after our input print the height again. Yes.
And we have height 50. Okay. Should we now show the debugger? Do you think this is more important than questions? But so far we do not have that many questions in the chat, so maybe we don't need that much time for questions at the end.
Yeah.
Do we show
the
debugger?
We can do
we will show the debugger.
So of course printf is a pretty easy way to look at your variables and check out values, but there is a more elegant way, which also is easier if you have a larger program. So maybe instead of doing this printf, we can do something different. Should we show the slides first?
Now we go through it again. So we have on the left-hand side of our editor, we have this symbol with the bug.
Yes, run and debug. Right here. And here, the first thing, if we press this button we have here, we need to select LLDB.
Yeah.
Then this is normal, we don't have any configuration. We press OK. And then automatically this configuration file is opened. And in here we need to specify our executable file.
So here we have the line program, and then you need to specify the file that the computer can read.
Yes.
So without the .c, so which you also specify in the clang -o.
Yes.
Okay.
So, yeah, the debugger, which we'll see soon what this is, can find our program.
So we can close this again.
Now we need two more things.
Yeah.
First, now to actually use the debugger, it's a tool where you can run your program and then stop at some time, which you specify, and then you can look at all what values the variables have in other state.
So maybe we want to stop after the scanner.
Yeah,
so
so maybe just right before our main exits.
So you just press next to the line number.
Yes, and this will create something called a breakpoint, which tells the debugger to stop here so we can inspect our variables.
Yeah.
And now the last thing we'll need is here, when compiling our program, we'll need one additional flag, -g. So our debugger can work with our program. This is necessary.
So this in this hello world without the C, more information is now stored that we can that the debugger, which we will show now, then has more information available.
Okay, and now we compiled with -g. We set the breakpoint. We can now run our program and debug it. We can click here, start debugging.
Then we need to go to the terminal because we need to enter the input.
So let's type 50. And now we can see here in the editor, okay, we arrived at the breakpoint. Here in this line, or right before this line, is currently the point where our program is. And up here in this variable window, we can see, okay, the height variable really is 50.
This is really convenient. So we don't need to print this to verify, but we can just stop somewhere in our program. Okay, so this worked now with the height. Maybe we can continue now with the other two inputs. Yeah, we have the small diameter and the large diameter.
Like this is also in centimeters. And now we'll scan F. Well, actually, we need a variable where we store the small diameter. So let's create one right before, like this. Yeah, we can set it to 0 initially, and then right here, we'll assign the new value, which is read by scanf.
Okay, yeah, maybe we continue also with the large diameter and then test again whether all the inputs are correctly stored. Meanwhile, I answer a question in the chat. With an additional breakpoint, I have to compile again. You only need to compile again if you change something in your program. But if you just set more breakpoints or want to debug multiple times, this is not necessary. So you can stop very often. You can change the stop points, the breakpoints. You don't need to compile only if you change something. Okay, so you have now, you need the end before the large diameter in the scanner.
Okay.
Okay. So now we changed something. Now we need to compile again. So
first we need to compile.
I think you need to go in the other terminal here. Because we changed something, now the new version is also available for the computer. And now we can again debug. We still have the breakpoint at the very end, so we have these inputs. I maybe do already the realistic example. 30, 36. Now we have the breakpoint and we see that...
Okay. Apparently it worked. I see some questions about the variables. someone asked, is it more efficient to create the variables right before you need them, so like I did here, or if it's better if we do it all on top? And this doesn't matter. It's just the same in your final program, so you can do it in any way you want. And then also, why do we need to assign this initial value, even though scanf directly assigns a new value?
I mean, basically it's not necessary, but maybe in a more complex setting you later think that something is stored inside, but maybe you do not store something inside it because there is it will not be that linear that you go step by step, but maybe something changes or some parts of the code are executed, some parts are not executed. We will see this in today's lecture, and maybe in some flow you forget to initialize it with a value, but if you really have set it to 0, then you are sure that the value 0 is contained. Yeah. Otherwise, an arbitrary value is inside
it's just
the variable.
Good practice which helps you preventing errors. So it's not necessary, but you should do it because it will help you spot errors. I see many things about efficiency also, but basically it doesn't matter for us because efficiency is a really complicated topic, and right now we want to focus on writing programs which do the things we want.
Yeah.
So this is our only goal right now. Okay, so then let's tackle this formula here.
Yeah, so the first thing, maybe copy
I'll copy it down.
Yeah.
The first thing we need is pi. So maybe let's create a variable.
I wrote it also on the top if you... but probably this is already enough because we already have this ugly formed wine barrel, so we're not doing it completely correct. Yeah?
Okay, and now we could basically just write down this formula and just translate it to suitable C instructions. So this big V stands for volume, so maybe let's use a more descriptive name. And then we have pi, so this equals now pi times the height divided by 3.
So just height divided by and just a 3. Yeah, okay. Times. Oops. Now we need the large diameter squared. Yeah, but there exists a function which would square it, but squaring is just multiplying it. So we just multiply it with itself.
Yeah. So I think this should be obvious why we can do it this way.
Divided by 2.
Then we divide it by 2. And then we add the small diameter, also squared, so I'll do this in brackets again.
Divided by 4.
Divided by 4, okay.
Okay, this is really ugly now because this is such a long line and we only can read like the first 2, 3 names here. Can we do this differently?
I mean, we can either create variables, or we could split it up in more lines.
Okay, can we so split it maybe up a bit?
Yeah, just like this, maybe indent it a bit. So this is on the same height, and now we can all see it here.
Okay, so now it's pi times height divided by 3, and then with this large bracket, with the large diameter divided by 2 and small diameter divided by 4. We could now again execute the debugger, see if the volume is correct, but as the last step in our program is printing the result, we do this now immediately and check it via printf if we get the right volume.
Okay, so we get some volume now, but maybe it would also be a good idea to have some unit here, because what is this now? Is it liters? Yeah,
in liters, please. I want to have the volume in liters.
Okay. So let's just write liters here and hope that liters is correct.
Yeah, let's see. Yeah. So we execute it now without the debugger, and now we take the example from above.
So this should be 50 liters, okay, 55, 30, 36.
Ugh.
Okay, this is something different now.
This is completely different as the right result should be. Yeah. So if we go back to the calculation, yeah, we have done our calculation in centimeters, doing a volume on it. Okay, the result will be in milliliters. So we need to divide the volume by a factor of 1000.
So we can assign the volume again and divide it by 1000. Because we calculated with centimeters and we want to get to liters and we have a volume. So this is hopefully clear.
Maybe you can also insert a \n after the liters for a nicer printing. And check it again. So we need to input the values again, which we have
55, 30 and 36. And
it looks better.
It looks better, but it's still not the same as it should be 50.28, and down here we have 49 point something.
So maybe one of our calculations is wrong.
Yeah.
Maybe
pi wasn't exact enough.
I hope that it was exact enough, but maybe we can ask the chat now.
Yeah.
What could be the problem here?
I already see something because of the rounding from the divisions. So, okay, we have a division here. Okay, so we have an integer height and we divide it by 3 and then we get another integer. Okay, and we have here an integer multiplied with an integer, divided by also an integer. So this is an integer.
So we're always doing this integer division that we've seen before.
So, and because we have these in parentheses here, these are executed first. We know pi is a double. So somewhere it will be promoted because we have these decimals here. But these calculations, so this complete parentheses here only works with integers and now always cuts off our decimal places.
So how can we change this now? We can just, as we've seen before, we can just specify
maybe here.
Yeah, maybe we can say that this should be
a float
or make a double directly out of it because everything is double. And
then also for this one here,
to also say this is a double because then the large diameter is a double, the left side multiplied with the right side is also a double again, divided by 2 is then also a double.
So this is enough because here we have a double multiplied with an integer, so this becomes, so integer by double becomes a double, so we have a double here divided by an integer. So the integer is again promoted to a double because we have double and int, the integer is promoted and we have a double again.
Yeah.
Okay.
And now this volume divided by 1000, volume is already a double, so this is no problem.
Work.
Okay, then check it out. And now
we need the example again. Oh, okay.
Yeah,
now we have the same solution, but many points after the comma.
Yeah, so we can show this. Maybe we need this also in one of the weekly exercises. You can specify with the dot and then a number, in this case 2, how many decimal places should be after the comma. And if we write 2, we also get exactly 2 decimal places here.
Yeah. Also in the chat, why not make the variables double? This is a good idea. We can make this double.
Yeah.
Then we would need, of course, some different format specifier in the scanf. But if we fix this, then we wouldn't need this cast here.
Yeah, so this would also another option to solve this problem. Okay.
Yeah.
Then we go back to the slides for a very short second again. So we showed now the debugger during this example. This is maybe a bit too fast for you because we did a lot of things here. We have some information on the slide. Maybe this is not enough. I just want to show you that in the guide for the practicals, here in sub pages, debugger in VS Code, you press on it and then you see what you need to install. This is already pre-installed here. And then you really see the steps again, what you need to select, what you need to type, that you can execute the debugger. So if this was too fast now in the practicals, just go there.
There was a question in the chat, does %.2f round or cut off? Well, maybe you should just try this out yourself.
Yeah, and we don't answer more.
Yes.
Try it out on yourself.
Maybe you can then report back in the chat what's your conclusion.
In the lecture, for example,
Yeah.
if you need, you have now 15 minutes, then you can do this. Okay, so to on just to the right, yeah, summary. What have we seen today? We started with the hello world, so the very simple program. Then you told us a bit about data types and operators again as a recap. Then I rushed over the binary representation and the characters because it was only a recap. And then we really saw this first larger program where we calculated the volume of this barrel. Okay, now we have not so much time for questions as last time. We will wait a bit now if there are some in the chat, but we will not do this with the Slido today. And in approximately 5 minutes we need to stop.
There was a question, can you release the homework now already, please? The homework is already released in the Teach Center. You can find here the first coding session and the corresponding homework. It's already here. And so you can already do this. If you meant the assignments, then no, because there are a lot of work for our tutors to create them and they will be released later.
Yeah. So the assignment, the first assignment, assignment 1 will be released in 1 week and not 1 day before. And online GDB will be released at 6:15, and we will also not release them earlier because you should watch the lecture and then do the exercises.
You will need stuff from the lecture.
Yeah, and you should not code during the lecture. You should listen to the lecturers.
So are screenshots enough for documenting the homework? Depends on which exercise, but maybe just write a few words and not just screenshots.
Then we have the homework
in
1.
The homework 1 number 4 command. Yeah. Is it just a research exercise or do we have to show something? So you have to document the command you found. So in your homework, the document you submit, there should, under the section 4, be just a few sentences and a description about the command you chose and which you researched.
Yeah. And if you want to include an example, this is of course also allowed. If you want to write it in practice and show what it does, but it's not necessary.
I think also the question if they are allowed to use the math library. Yeah. And yes, so we have as we already see, this stdio. There also exists something similar for math operations. Then we could do this querying more elegantly. We won't show this now, but yes, you can use these. Okay, I think no more questions are popping up so far in the chat. So I think we conclude now. Thank you for being at the practicals. In 10 minutes, the lecture will start and with more interesting stuff about programming. And we will meet each other in 1 week again. So have a nice weekend. Maybe we can already say this and see you next week. Yeah, do the weekly exercises.
Yeah. Okay, then bye.
Bye.